Hey everyone, welcome back to another fun and exciting Algebra 2 class. Today we are going to be looking at lesson 3.4. And what this is, lesson 3.4 is talking about inequalities and how to graph them, but not just regular inequalities, because I think you remember how to do that from last year. This is talking about how to do it with nonlinear or with quadratic inequalities. So if you'll look down here at the screen, I'm just going to get right into it because that last lesson that we did was really short, and so I'm going to make up for it today in this lesson because it's going to be really long, okay? At least I think it's probably going to be long. It's fairly complicated. So back in Algebra 1, we learned how to do the line graph, and this was 0, 1, 2, -1, -2. Let's say our point was here and here, okay, and we filled this in. You remember this. Well, when you circle it, you remember that is only because it's greater than or less than, okay? What if it's greater than, less than, or equal to? Then we would fill that in. Okay, I'm sorry about that thing. I'm using a new pen, and I'm not sure why it's doing that, but it keeps messing up on me. So these are the graphs. Okay, these are the line graphs, and these are the greater than, less than, equal to. And then what we would do is we would test a point. Remember testing the points? So we would test point 0, and if 0 worked, then we would fill in the middle. If 0 did not work, and 2 works, so we test 2, and 2 works, we would fill in up here. Remember this? Okay. I think most of you probably do. What we're going to do today, though, is we're going to take this to the next level, and we are going to do these with quadratics, with nonlinear, something that has an exponent. We'll put it that way. Okay. So some of the basics, remember, we're going to test points. Some of the basics, remember that if it's greater than or less than, then we just circle the thing. If it's equal to, greater than or equal to, then we color it in. And yeah, so those are kind of some of the basics. So let's go ahead. First thing that we need to do is we need to solve the equation. So let's try one. X squared plus x is less than 12. If you remember from standard form and from all the quadratics that we've been doing, we want to get it into equals 0. Well, just because it's a less than sign doesn't mean that it's any different. We want to get it to equal 0 or less than 0. Okay, so we're going to subtract 12 from each side. That's going to cancel that out. So we're going to get x squared plus x minus 12 is less than 0. We're putting it in standard form, in other words. Now, what we want to do here, and this is kind of tying some of those other lessons together that we've done. We want to find the possible zeros, or in graphing we call it the critical numbers. How do we do that? We factor it, okay? And so we're going to come down here and we're going to say, so this is going to be plus and minus. And both of these are going to be less. We're going to set them equal to 0, okay, if you will. Now, it's not an equal sign, but we'll call set it equal to 0. And we're going to factor this -12, and that's going to factor out to 3 and 4. So 4 would be the bigger one since the middle number is positive, and then a 3. Okay. And sorry about that again. My pen is messing up, and I don't know what's wrong with it. It's brand new. It's really nice. I like my pen, but it's doing some funny things on the screen. So if you see random lines, just go on there. Don't pay any attention to them. And the weird thing is I can't figure out how to erase them. It's like it's doing something where every time I move my mouse, it puts this weird line, and then I can't erase it. So sorry about that. If you see it, that's what's going on. I'm going to figure it out, though, okay? So go ahead and move this over, and this is going to be x is... See, there it goes again. I don't know what's happening right now. X is less than Do you see what I mean now? Do you see what's going on? This thing, it's possessed. Is less than 4. Negative 4, sorry. All right, and this one is going to be x is less than positive 3 when we move it over there. All right, so now what would you do? Well, what we would do now is we would put those points on our graph. So let's go over here and we'll get a straight line and we'll start graphing some stuff on here. So we'll put a 0, 1, 2, 3, 4, 5. And that'll be enough. So positive 3 gets a circle. So we'd come to positive 3. I can number these 1, 2, 3, 4, 5. And then this would be negative 1, negative 2, negative 3, negative 4, and negative 5. So I'm going to come up here and I'll use yellow and I will put a circle on 3. I don't color the circle in because it's not equal to. So if that had an equal to line under it, then I would color it in, but it does not. So then I would come over here to negative 4 and I would put a circle on negative 4. Now the question becomes, what works? What works? What do I color in? Do I color this in the middle? Do I color this in up here? Do I color this in up here? So what we have to do is we have to test points. Remember this from Algebra 1? I'm going to choose 1 point from outside, 1 point from inside, and 1 point from outside on the right. So 1 point outside on the left, 1 point from the inside, 1 point outside on the right. What does that mean? What does that mean that I have to test the points? Well, what you do is you plug them back into the original equation. So we're going to come back up here to this original equation, and I'm going to test these points. So I'll do it down here. We'll do, I think it was x squared, look over here, x squared plus x equals or is less than 12. Sorry. All right, so what I'm going to want to do is I am going to want to just plug in random numbers. We'll start with the negative 5, and we'll see if the negative 5 works, because that's outside to the left. So negative 5 squared plus negative 5 is less than 12. Negative 5 squared is going to be 25, because negative 5 times negative 5 is positive 25. Minus 5 is less than 12. So 20 is less than 12. Yes or no? Nope. And so this one does not work. All right, so I'll just erase all this and I'm going to try it again. I'm going to put new numbers in there. So this one we know over here doesn't work. You don't have to put that X there. I'm putting it there so you can see it though. All right, now let's try the middle one. Let's try 0. 0 squared plus 0 less than 12. Well, 0 is less than 12. Good. That one worked. So I'll erase this real quick and we will go back there. And that means that everything in the middle works. If one thing in the middle works, it all works. Trust me. We could try any number right there and it would work. Now we'll try the other 5 just to make sure. Probably it won't work. If you've been doing these long enough, you understand how this kind of works. But we'll try it just to make sure. We don't want to miss one. So 5 squared plus 5, that's 25 plus 5. Well, that's 30. No, that one's not going to work. So there we go. That one would not work. So our solution to this, our graphing solution would be this right here. This middle section is what we'd color in. Okay. And there you go. That is how to do a polynomial inequality. It would be lovely if they were all that easy, but they're not. Sorry. If you would go ahead and turn to the next page, page 141, 141. Whoa, what is going on here? Well, do you remember at the first lesson where we learned how to find the possible zeros of the equation? whenever you have like a cubed or to the sixth or something like that, and we don't know how to factor it, we learned how to find the possible zeros. What was that again? Well, that was the constant term, the factors of the constant term over the factors of the leading coefficient. So, x cubed plus 4x squared plus x minus 6 is greater than or equal to 0. And what we have to do first here, before we can start doing anything else, is we have to find the possible zeros to this. Finding the possible zeros. So here's what I would do if I was you. Now, I'm not you, but if I was you, I would use the critical number, or I would use the rational root theorem, and that's what we learned in the first lesson of this chapter. And what that says is kind of what I reviewed just a second ago. If we take the factors of the constant, I'll put CON, over, and this was the positive and negative factors of the constant, over the factors of the leading coefficient, I'll call it the LC, plus minus factors of the constant term, 6, over factors of the leading coefficient, in this case, 1. Those give me my possible zeros. So, what are the factors of the leading coefficient? Well, we have a positive, negative 1, positive, negative 2, positive, negative 3, and positive, negative 6 over 1. Well, that's good. I love it when the leading coefficient is 1. That makes me happy, because I can just get rid of it. Just 8. Okay? And so these are my possible zeros. Well, what does that mean? What are my possible zeros? Okay, this is how we factor. This is how we figure out how to factor this. Remember when we had to divide it, synthetic division and all that good stuff? So what I do here is I first of all try to find 1. I try to find the base that works. So let's try positive 1 first. Let's see if positive 1 works. So positive 1 cubed plus 4 times positive 1 squared plus positive 1 minus 6 is greater than or equal to 0. So let's see if this works. Let's see if we can get this one to work out. And we get 1 plus 4 plus 1 minus 6 is greater than or equal to 0. 1 plus 4 is 5. 5 plus 1 is 6. 6 minus 6 is 0, is greater than or equal to 0. And that is true because it could be greater than or equal to. Okay, so we have found I don't want to say we're done, but we have found our first critical number. We have found the first number that's going to work. Okay, and so here's basically what we found. We found that x plus 1 is greater than or equal to 0. This one works. That's a good one. Okay? And so what we want to do now is we want to solve this by division. We want to solve this by factoring. Okay? And the easiest way, in my opinion, is by division. Okay? Synthetic division. Specifically. Okay, and so if you remember how to do synthetic, you can do the other way, the other type of division too. Or in this one's interesting. Let's just do it. Okay, let's just do it. Okay, so what I've written here, I kind of got rid of all that other stuff, and I wrote down k equals 1, because that's what we just figured out with our factoring. So we got our zeros. That's what we just did when we got our possible zeros. So we found out that one of those is 1. Our k is 1. So when we go over here, we would put our 1 inside of our box. Okay, this is synthetic division here. This is probably the best way to do it. You can do it regular division too. But then I'd take my coefficients, which that one's a 1. So then I have a 1, a 4, a 1, and a -6. And then I would put my line down here. I bring my first one down. And then I say 1 times 1 is 1. And then I add 4 plus 1 is 5. 1 times 5 is 5. 1 plus 5 is 6. 1 times 6 is 6. -6 plus +6 is 0. So that is a good factor. So that means that that one factored out because we had no remainder there at the end. And so our new polynomial, okay, is, so we're getting rid of this one. This one's our old one. So we have our first factor is the one with the +1. So when we move that over, it's -1. Remember that? Remember that whole formula thing? It changes the sign. So we got a +1, and then when we make it a factor, it's the -1. So basically, we're moving it to the other side. And then we end up with this right here. Okay? And so this is going to be our x squared term. And this is going to be our x term, and this is going to be our constant term. Okay, and so there are 2 factors. But the book says, if you're looking on page 141, the book says that we have to fully factor this. And I want you to see something. This is going to happen every once in a while, and this happens here. That can be factored again. So that's kind of cool. We're not done with it yet. So this is still a factor, so we keep this one going. Sorry about that. So this is the x minus 1. And then this one can be factored out. 1 and 6, 2 and 3. 1 and 6, 2 and 3. The 2 and 3 give us 5 in the middle, so this is factorable. This would be x plus 2, x plus 3. So I keep factoring it. I keep going with it until it can't be factored anymore. And that's where we are now. We have x minus 1, x plus 2, and x plus 3. Now we have to set all of those equal to 0 or to whatever it was up here, greater than or equal to. So x minus 1 is greater than or equal to 0. X plus 2 is greater than or equal to 0. And x plus 3 is greater than or equal to 0. And, you know, some of you are like, I don't even do that, Mr. Steve. I just see, okay, if it's 1, I just, -1, I just do +1. If it's +2, I just do -2. If it's +3, I just do -3. Okay, good. I'm doing this to show you the process, to show you what goes on. But if you can do it in your head, fine, no big deal. So we move this one over, and we get x equals +1. Well, technically, x is greater than or equal to +1. Here we get x is greater than or equal to -2. And here we get x is greater than or equal to +2. -3. Sorry about that. Losing my mind just a little bit. All right, so there we go. Now what we do, finally, we are ready to put it onto a piece of graph paper or just onto this line graph right here is fine. So I'll go through here and 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I think that's about all we need. And so we're just going to now graph our, and remember, they're equal to as well. And so we're going to color them in. So we'll put 1 on 1, and we'll color it in. We'll put 1 on -2, and we'll color it in. And then we'll put 1 on -3, and we'll color it in. Now what you want to do is you want to test. We have a lot of test points now. Okay, and so we want to find test points in between all of these. And this one's going to be a little bit tricky in between that one. So this one, and this one. So we have 4 test points. And so let's test point -1, -2, -3, -4, -5. That looks like a good one. Let's test -4. That's a good test point. Ooh, yuck. Well, -2.5. I don't like it either, but it is what it is. Here's a good one, 0. That's a good test. 0 is always a lovely test point. And then that's 1, and that's 2, and that's 3, so we'll do 2. So I've basically selected a test point from every section of that graph right there. One from in between these ones, one in from between these ones, one up here, and then one down here. I've picked a test point. Now, you can pick different test points. You don't have to pick my test points. All right. So what's going to happen is we are now going to plug it in to the original. I'm not going to do all of this work, okay, because it's just things that you know how to do. What's the original? Well, it's up here. Let me get rid of this real quick. It's right there. Let me get rid of this one. It's x cubed plus 4x squared plus x minus 6 is greater than or equal to 0. So now you're going to test all these points. You're going to test the -4. Put the -4 in for the x. Use your calculators, please. Save yourself some time. Don't do it all on a piece of paper. It's wasting your time. So use your calculator. Plug it in. Does that work? You can pause the video. Try it. Okay. It does not work. The next one, in between here, this one right here, does it work? Well, when you put that point in there, -2.5, it works. So we're going to color in between there. 0, does it work? You might be thinking, oh, it probably works because that one in between it worked. That doesn't mean anything. You need to test each one. This one does not work. Okay, and then this one up here, we tried the number 2, and it also worked. So there is our solution. Okay, and you don't need to put these x's there. I'm just putting those x's for you to be able to see it. Okay, so there's our solution. We would color in between the -2 and the -3. We would color in anything greater than +1, and that would be the solution for that question. Okay. Wow, big. Oh, let's write it. Let's do one more thing. Let's take it to the next step. Let's write it in our notation, okay, our interval notation. So how would we write that thing in interval notation? Well, it is included at -3, comma, -2. And then it skips, okay? And then I would probably write the word or, maybe, or just write nothing. I don't really care what you write there. Or, and then again, we're included at 1, and then until infinity, because that goes forever, and we can't include infinity, so that would get a parenthesis. So bracket included, parenthesis not included. And so this would be the interval notation answer for that one. Graphing answer, interval notation answer. Okay? Woo, that was fun, right? I told you. This is going to be a little bit of a long process. What happens on these if you get things that repeat themselves? You just keep doing the process over and over, find the critical numbers, and you just keep plugging stuff in. You could get 10 points, then you'd have to plug in every single one. The book probably won't be that mean to you, but you just keep doing the process over and over again. Once you get the process down, you just use the process, solve the process, plug in, test the points. Does it work? Color it in. Doesn't it work? Leave it blank. Okay? All right. Hope you learned something today. We'll see you later. Bye-bye.